Okay, this video accompanies the last page in the problem set for 6.2 on trapezoids, focus on trapezoids. And again, like on the others, for this one, if you want partial credit, all you have to do is just copy the video notes. The problems are actually on the other side. If you want full credit, though, you also need to, in addition to just copying the notes that we're going to talk about in the video, you also need to complete the asterisk mark problems to get 10 out of 10 on these. Let's see what we got. So trapezoid, exactly one pair of parallel sides. If it's isosceles trapezoid, we have two congruent sides that we call the legs. And the trapezoid with congruent legs we say is an isosceles trapezoid. Isosceles trapezoids are going to have congruent base angles. Okay, base angles of isosceles trapezoid are congruent. The median, the mid-segment of a trapezoid, is the average of the two bases, or double the length of the median is the sum of the two bases. And also, this mid-segment or median is parallel to the two bases. So they do some examples for us here. 6 and 12 is 18, divided by 2 gives us 9. Here, these added together gives us 8x. Looks like plus 10 equals 10x. 8x plus 10 equals 10x. And x is going to be 5 for this one. And here we have what's marked as an isosceles trapezoid because of the congruent legs. That means that these two have to add to 180 degrees. If this is a 70, this is a 70. That gives 140. Altogether, 4 sides makes 360. That means that 360 take away 140 is 220. 360 take away 140 is 220. And each of those is equal. Divided by 2, we get 110 degrees. So I might have said it a little bit different way than what they did there. Let's look here. So we're going to do the green circled ones in the video, and you need to do the asterisk ones in addition if you want full credit. So let's look. The two bases added together divided by 2 makes 16, or double the 16, which is 32, is going to be equal to the sum of the two bases. Take away 20 from both sides, x must have been 10. So look at number 4. This mid-segment, or median, is double the sum of these two. So twice the median equals the sum of the two bases. So this gives us 8x minus 2 equals 6x plus 2. Let's see, let's go this way. Minus 2x, and take 2 away, equals minus 4. Divide by negative 2, x is going to be 2. And we just need to find out what x is. But if we want to check it, we get a 2, we get a 7, and we get a 12. And 2 and 12 is 14, divided by 2 gives us the 7. So we know those numbers are going to work out. Okay. This one, base angles are congruent. And going this way, they're going to be supplementary. So you can figure out what all those different angles are. Over here, same idea. All of these have to add up to 360. And you got sets of congruent angles at the base. Here you got one, it's isosceles, one angle is 48, that means there's got to be another angle that's 48, and then the other two angles are going to be congruent, and altogether, since it's 4 sides, they need to add up to 360. Okay, let's do number 8. Two congruent angles. If an isosceles trapezoid has, so they're not giving us a diagram to go with this one, so I want to supply a diagram. So I'm just going to sketch. It says it's isosceles, so I'm just going to sketch what could be an isosceles trapezoid. Two congruent angles have measures 5x minus 17. This other angle over here then is going to be 2x plus 13. Doesn't have to be to scale. And then we want to find out what each angle measure is. So these two angles need to be congruent. So 5x minus 17 equals 2x plus 13, and we can find out the x that makes it work out. Add 17 to both sides, get 30. Take away 2x from both sides, we get 3x is 30. X is going to be 10. Now if x is 10, that means that this is going to be 50, take away 17, which is 33. This one is going to be also 33. These same side interior angles are going to be supplementary. So 180 take away 33 is going to be 147. And this one over here also has to be 147. So let's check and see. This gives us 294, 324, 327, 37, 47, 357, 360. They do add up to 360, so it works out. Let's move on down. Here they're giving us example 2. Now we could look at this, if we had a line through here, we could actually look at a triangle as sort of being like a trapezoid with one of the sides as a 0. So one of the bases is a 0. So if we want to find out the length of this XY segment, basically we could do 0 plus whatever MN is divided by 2 is going to be that. So that's, but now if we wanted to find out what MN is, we could do XY plus BC divided by 2 to give us MN. Again, to find XY, MN plus A, which is a 0 length, divided by 2 is going to give us XY. So that's kind of like a neat little pattern trick you can pull on this. So let's see what we got down here for number 9. If XY is equal to 9, and then MN is equal to, we don't know, and BC is equal to, we also don't know. So let's see what we got here. Using this MAN triangle, with what I said before, 0 plus question mark equals twice 9. Twice the midsegment is the sum of the two bases. One of the bases happens to have a length of 0. The other one we don't know, which we have as a question mark. So 0 plus question mark equals 18. Question mark must be 18. So if this is 18, 18 plus 0 divided by 2 does give us 9. So MN is 18. Now, what did we find out? Oh, so what's BC got to be now? So if MN is 18, now we have a 9 and an 18. These, using XY and BC, these two bases divided by 2 must have come out to be 18, or twice 18 is equal to 9, and we call this one X. We have twice 18, twice the midsegment or median, is equal to the sum of the two bases. So using this XYCB trapezoid here, we're going to have 9 plus X is equal to 2 times 18. Twice the median is equal to 9 plus the base. So 36 is equal to 9 plus X. Take away 9 from both sides, 27 must be X. So BC must be 27. Okay, similar reasoning. You need to do the other problems on the worksheet. So kind of like erase these notes and then go with what you're given on the other one. Okay, let's look at number 12. We'll do like an argument about how we know that this works out. So they want us to prove that ABCE is a parallelogram. So parallelogram, opposite sides are going to be parallel. Another thing with a parallelogram, the diagonals are going to bisect each other. Opposite angles are going to be congruent. And that's really about it, how opposite sides are congruent. So if we get pairs of opposite sides congruent, it's got to be a parallelogram. Pairs of opposite sides parallel, it's got to be a parallelogram. Opposite angles congruent, it's got to be a parallelogram. Diagonals bisecting each other, it's got to be a parallelogram. So there's a couple of different ways we can go about this. Let's see what we got. To start us out, they're saying that CD is congruent to CE. So CD and CE are congruent. Okay, so what does that do for us? If these two are congruent to each other, then this is an isosceles trapezoid, or isosceles triangle, and from that, we know that angle D and this angle here, angle CED, are going to be congruent to each other. Okay, what else? Also, we're given that this triangle is isosceles, or this trapezoid is isosceles. So this CE side is going to be congruent to the CD side, which is also going to be congruent to this BA side. So all of these are going to be congruent. Because it's an isosceles trapezoid, then these two sides also are congruent to each other. Now, what does that do with the angles? Since it's an isosceles trapezoid, this angle at D has to be the same thing as this angle at A. Okay, so it does that for us. Now this angle at A is going to be supplementary to this angle AEC, because together this is a linear pair. And here we would have a pair of same side, using, if these lines were parallel, if this BA side was parallel to the CE side, that would give us same side interior angles being supplementary, which would let us say that those two sides are parallel to each other. So that gives us one set of parallel sides. See what we can do for getting these sides parallel here. Now, if these sides were parallel, then these alternate interior angles would be congruent, and I think that's what's going to do it for us. Let me switch over here to black. So let's see what we can do. So if this BC side was parallel to the AD side, these alternate interior angles would be congruent to each other. And these angles would all be the same angle. So that would give us opposite angles congruent. And with alternate interior angles, we would know then that, well, okay, if they were parallel, these alternate interior angles would be congruent. These alternate interior angles are congruent. We know this was congruent though. If they're parallel, they're going to be congruent. Because these sides are parallel, these corresponding angles are going to be congruent. Because these sides are parallel, these angles are going to be supplementary. Okay, another thing we could do, I can't get the parallel thing out of this other side yet, but if you got one set of sides that are both parallel and congruent, that's also enough for it to be a parallelogram. So if I could get that these sides were congruent to each other, or these two were congruent to each other, that also would do it for us. So isosceles trapezoid ABCD, that means this side and this side are congruent, and this side is congruent too because it's isosceles with the CD side. That's enough there to give us a set of parallel sides that are both parallel and congruent to each other, which can cause this to be a parallelogram. So it's not exactly the best set of reasoning, but it kind of goes like this. You got this isosceles trapezoid, which gives you these outside legs congruent to each other. They're telling us that we have a equilateral or equal angular, not equal angular, we have an isosceles triangle inside here. Which lets us say that these sides are all congruent. And then using the base angles, because it's isosceles, as being congruent, that also gives us that we have these sides parallel to each other because of alternate interior. If alternate interior angles are congruent, sides must be parallel. But then from the isosceles trapezoid given information, along with the triangle being isosceles, that lets us also know that these sides are also congruent at the same time that they're parallel, which is enough to force it to be a parallelogram. So that was not exactly the easiest proof.